Good morning, students. Today we'll study about the structure of heart, its location, its exact location in our body, then the number of chambers present in the heart, the vessels that supply blood to the heart, that receives blood from the heart. So all the vessels that are involved in the supply of blood and receiving the blood in the heart. Then a number of valves present, where it is present, where these valves are present, what is the exact location, as well as what is the function of these valves in the heart. In the today's class we'll discuss about coronary arteries, role of coronary arteries, and exact muscular arrangements are in the heart for the pumping function. And as you know that heart is a pumping organ, so we'll basically study about the details of the structural details, just to show that why these structures and how these structures help the heart to perform its function. The function of heart is pumping to the nearby place, pumping to distant place, and what are the structures that support this function. So let's begin with the first term, which is location. The first point that we'll discuss today is location. Location, according to as we say, or most of us will say that heart is located in the left side of our body, or it is just left side of our body, but the exact location is it is located in the center, slightly tilted towards left. So that location is located in the center of the chest cavity, slightly tilted towards the left. Since it is a triangular muscular organ, so this lower part it is tilted towards left, which gives a feeling that heart is located in the left side of our body. Next topic is the chambers of heart, number of chambers. So let's begin with the structure first and then the number of chambers, what is the role of these chambers, and muscular structure of these chambers. So let's start with this. As you can see here in the diagram, the dotted appearance is just a symbolic representation for the muscular arrangement of heart. Actually, the muscles are not striated or striped like this. Just and this appearance is given just to differentiate between the chambers and the muscular region. Here, it is having 4 chambers. The upper 2 is termed as auricles or atrium. The lower 2 is termed as ventricle. Now, which is the right and left side of the auricle? As you can see, I have written here right and left, and according to me, it should be this one, should be right. But when we are making a diagram, in diagrammatic representation, the left side of our body is written as right of the diagram. So here, the left of my body is the right auricle. This one is the right side of my body is the left auricle or left side of the diagram. So these are the right auricles and right ventricle. This left auricle and left ventricle. These 2 auricles are separated by a thin septum, thin muscular wall, which is termed as septum. Since it is between 2 auricles, it is termed as interauricular septum. Interauricular septum. In between 2 auricles. This septum is present between 2 ventricles. So this septum is interventricular septum. Now as you can see in the diagram, the muscles in the auricular region is thin walled, thin muscles. Here the muscular arrangement is thin muscles. Here there are thick muscles in the ventricle. What is the reason behind? Because for every structure there is a reason behind this, behind it. And what is the reason is, in the auricles have to supply blood just to the next chamber. They have to supply blood to just to the next chamber, which requires a little contraction. Little contraction, less force. That's why the the muscles are thin. Thin muscles. Here, in the ventricles, they have to pump to the distant organs, like right ventricle supplies blood to the lungs, while the left ventricle supplies blood to the two different parts of the body. They have to supply blood to various distant places. That's why they require a strong muscular contraction to create a pumping force. Strong muscular contraction to create pumping force and to exert pressure, a huge pressure to pump blood through the vessels to distant places, and this requires a strong force, and that's why the muscles are thick muscles, thick walled structure. These chambers are thick walled. So this is the reason behind the thick muscular walls of the lower chambers, thin muscular walls of the upper chambers, just because they have to supply up to this chamber, but these two have to supply blood to distant places. Next is the number of valves. Before making number of valves or this, because I have not made it completely, I want to make a clear basic structure of heart: two chambers, interauricular septum, two ventricles, interventricular septum. Now from where they receive blood? They receive blood from, as you can see, that this left complete the right chamber. The right chamber is for the right part of the heart is for deoxygenated blood. While the left part of the heart is for oxygenated blood. Now it receives deoxygenated blood from where? It receives with the help of this, which is termed as superior vena cava. Superior vena cava, it is a vein which receives deoxygenated blood from the parts above heart, that is the chest cavity, head and neck and head region. So the parts that is above heart, which is the chest cavity, neck and head portion, the deoxygenated blood from these parts are received by superior vena cava and poured into the right auricle. The deoxygenated blood from the lower part of our body, is received by inferior vena cava. Inferior vena cava, the parts which is below heart, from all the part of below heart, the deoxygenated blood is received by inferior vena cava and poured into the right auricle. When it receives blood, what is the phase? Which is the auricles are in a relaxed phase, which is termed as diastole. Auricles are in diastolic condition. In diastole, they are in relaxed condition. When it gets filled up, completely filled with blood, it contracts. Now after diastole, the second phase is systole. So diastole, after getting completely filled with blood, it sends the blood to the next chamber. It contracts. That contraction phase is termed as systole, and during that phase the blood from the right auricle is pumped to the right ventricle. When the auricles are in systolic phase and the ventricles are in diastole phase. So So now it becomes systole, contraction, diastole, relaxation. Whenever they receive blood, they receive only when they are in relaxed phase. So this is, they receive blood in a relaxed phase when they are in diastolic condition. During this, they pass through a valve. This valve is, it contains three flaps. Three flaps, one from this side, one above this, and the third from this side. Three flaps, one above the other, and what they allow the movement. I am showing by only two flaps. What they allow the movement like this. But the opposite movement, if the blood, when the ventricles are in contraction phase, the blood may come into the auricles. To prevent that, these flaps are arranged in such a manner that they allow the blood to flow in a unidirectional manner from auricle to ventricle only, not from ventricle to auricle. So the valve is the tricuspid valve, TC. Tricuspid here, bicuspid valve. Bicuspid means two flaps. Bi means two. So it is having two flaps. This one, three flaps. Tricuspid and bicuspid valves. Tricuspid and bicuspid, it is in the right auricular ventricular area. Bicuspid in the left auricle and left ventricle area. So this is the, and they allow blood to flow from auricles to ventricle, not the, so it prevents, what is the role? If we mention the role of valves to prevent backflow of blood. Backflow of blood. Role of valves is to prevent backflow of blood. Next is here. Next, I have explained this once again. I am explaining this structure so that I will move to the next valves and I will rub all these parts. Here, from blood from the superior vena cava, which is the part from the parts above heart, that is chest cavity, neck and head, all the portions, the blood from all these portions, the deoxygenated blood is poured into the right auricle. The blood from lower part of the body, the parts lower than the heart, from there the blood, the deoxygenated blood is poured into the right auricle. The auricles at that time are in diastolic condition, relaxed condition, but when they get filled up, they contract, and that contraction phase is termed as systole. Systole here, and then the blood is poured into the right ventricle. Ventricles, when the auricle is in systole, the ventricle is in diastolic condition. Now this, I'll rub this. These chambers, so that it would be easier for you to understand all other valves present here. Now this, and this, these two valves are tricuspid. This is bicuspid. This we have studied, so I am writing with blue. Now the new. From here, this part, the ventricles, one vessel arises, and this vessel, is termed as pulmonary artery. Pulmonary artery. It receives deoxygenated blood. The first artery which receives deoxygenated blood, otherwise artery always carries oxygenated, but this is the exceptional case. Pulmonary artery receives deoxygenated blood from the right ventricle. At the end of this, semilunar valves are present. What are these semilunar valves? I will explain you later on. Now one more vessel which arises from this part and it carries blood to all parts of the body. It carries blood to all the different parts of the body. So this one, I'm making it just like this. This structure, it arises from the left ventricle to different parts of the body. Different parts of the body. This is to lungs. It carries oxygenated blood. And now what is the name of this vessel? This is aorta. Yes. Here also semilunar valves are present at the end. Now what is the role of semilunar valves? Name semi. Semi means half. Semi, half. Lunar, moon. So this shape of the valves is like half moon. This like half moon, that's why the name is semilunar valve. These valves are pocket-like structures. Pocket-like structures, the half moon structures, they are arranged in such a manner that when the blood flows back, if in any condition, if the ventricle is in relaxed condition, then there may be chances that it would come back. So this, if by chance it comes back, then this pockets would get filled up with blood. It closes the valve. This pocket-like structure, the semilunar valves, which makes a pocket-like structure which holds the blood, and these valves gets closed. Closure prevents backflow. So here also the role of valves, semilunar valves prevent backflow of blood from pulmonary artery to the ventricle, from aorta to the right or left ventricle. So this is, the role is basically preventing the backflow of blood from these vessels. And this was about the number of vessels. Now here one structure is present which is termed as, in this part, it is the pacemaker. Pacemaker or sino-aortic atrial node. Just towards the interauricular septum. Avian node is present. Avian is for atrioventricular node. Ventricular node. From this, the impulse for the contraction arises. Just below this is a bundle of fibers, and this is termed as bundle of His. From here, from the bundle of His, the fibers, various fibers arise, and they along with the ventricles, they move along with the ventricles, and that is termed as Purkinje fibers. Purkinje fibers. Yeah. From the sinoatrial node, which role of sinoatrial node is to initiate impulse. It is carried over to the AVN. Location is towards the interauricular septum near the cuspid valves, and just below it is a bundle of fibers that which is termed as bundle of His. It carries impulse along with the interventricular septum and along the ventricular muscle. These muscles, the impulses are carried by these fibers throughout the heart to create pump and contraction and relaxation in the heart, and this it is initiated by the pacemaker. This is all about the structural details. In the next class, I'll explain you about the clotting, which we have missed in the previous class. So just the process of clotting of blood and the role of vitamin K and calcium in the process. Thank you students for attending the class.